All right, these are the answers to page 5 and 6. 5, we have a graph of a velocity function, and we are told that it has horizontal tangents at 1 and 4, which is what it appears to have, and at time 0, the particle is at a position of 0. So, part A. On the interval 2 to 3, is the speed of the particle increasing or decreasing? Can you justify? So there's a couple ways to think about this. As I look at where I'm at 2, I have this speed right now, whatever that value is, okay? But when I get to 3, I have a speed of 0. So I'm heading towards a speed of 0. And if I'm heading towards a speed of 0, I must be slowing down, right? So I can kind of know for sure that I'm slowing down. But that could be difficult to explain, like to tell a grader I'm slowing down because I'm heading toward, the velocity is heading to 0. I don't know if they buy that or not. So there's a better explanation, and that is between 2 and 3, our velocity is negative. It's less than 0. But the derivative of this, which is the acceleration, is greater than 0. And so therefore they're going to have opposite signs, right? So we could say slowing down for the interval 2 to 3, velocity is positive or negative, but acceleration is positive. Because they have opposite signs, we are slowing down. Particle is slowing down. And again, you don't have to give a ton, but you want to make sure that you give enough. Don't use the words it, don't use they, don't use pronouns. Make sure you clearly say what you're talking about. Okay? Part B, during what time interval, if any, is the acceleration of the particle negative? So acceleration is going to be negative when velocity is decreasing. Acceleration is the derivative of it. If I have a negative derivative, that means my function is going down. So if I look here, my velocity is decreasing from 0 to 1 and from 4 to 6. And we cut it off at 6 because they cut it off at 6 here. If they hadn't, we might say infinity, and that'd be okay. When is the particle at rest? We're going to be at rest when our velocity is 0. This is the velocity, and this is at 0, 3, and 5. Okay, so that's easy enough. And when is the particle furthest to the left for the interval 0 to 5? So if you think about it, initially at 0, we have a negative velocity, so we're moving to the left from 0 to 3. So if you kind of trace it here at t equals 0, we're at some position. Then we head to the left, and then at t equal 3 seconds, we stop, we turn around, and we head back this way until t equal 5, right? So if I'm thinking about when was I furthest to the left, it must be when I turned around. So that'd be t equal 3 seconds. And that's just understanding, again, what that velocity equation is telling you about movement and things like that. Okay. Then we were given a table, and I do apologize, but I couldn't get the table to print on mine, so I just rewrote it here. It says find Ben's average velocity from 0 to 40. So our average velocity will be the change in position over change in time. That's what velocity is. It's change in position over change in time. So I want to take his position at 40 seconds minus his position at 0. That'll be the change in position, and I want to do that over the change in time, the 40 seconds it took. So his position at 40 was 9. His position at 0 was 100. And so I end up with a negative 91/40ths, and I don't have to reduce that or do anything to it. I can leave it like that. But this is average velocity, so it'll be meters per second. Okay? That's our average velocity from 0 to 40. Find Ben's average acceleration. Now this is going to be change in velocity over change in time. All right, so I want the velocity at 40 minus the velocity at 0 over 40 minus 0. My velocity at 40 was 2.5. My velocity at 0 was 2.0 over 40, so I get 0.5 divided by 40, which you can leave, or you can write as 1/80th, or you can make it a decimal if you'd rather. And this is going to be, because we're talking about acceleration, meters per second, or meters per second squared. Now, C says, based on your answers to part A and B, would you think that he's speeding up or slowing down at 20 seconds? 20 is in the middle of that interval. And if our average velocity was negative and our average acceleration was positive, those signs don't match. So if we had to take a guess, we probably would guess that he's slowing down. Slowing down, average velocity and average acceleration have opposite signs. That's really the only information you have to go on. You don't really know anything else about what's happening at 20, so that's our best guess on that one. And then D says, during his ride, does he ever come back to his starting position? So his initial starting position was 100, right? And you see that he goes up to a position of 136. Now, there's no reason for us to think that he came back to 100. He may have, but there's no reason to demand it. But when we look at the next position, they tell us it's 9. So to get from 136 to 9, you have to come back to a position of 100 at some point. So in this interval, we'd have to be at the initial starting amount. Okay, and then from here to here, we go from 9 to 49. Again, maybe he gets up to 100 and comes back down, or maybe he doesn't, but there's no reason to think that he has to. So we would say yes, he does get back, and it's somewhere on the interval 10 to 40. All right, and if you had to give more justification, you could say what the position was at 10, what the position at 40, and the fact that 100 is in between. We're invoking what's called the intermediate value theorem. Intermediate is in between, and so when we have a high and a low, and when we have a high value and a low value, and we're continuous, so you'd have to want to say the word continuous on that, then we have to hit every value in between. And that's what we're talking about there. All right, so that's the answers to page 5 and 6.